Hi, I'm Nitya, your tutor at Nityaz Academy. Let's learn the derivative and rates of change together, step by step. The slope between 2 points on a curve is the average rate of change, the rise over the run. Now imagine sliding the second point closer until the gap h shrinks to 0. The secant line tilts into a tangent line, and that average rate becomes the instantaneous rate of change at a single point. That limit has a name, the derivative, written f prime of x. It equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Geometrically, it's the slope of the tangent line. Physically, it's how fast the function is changing right at that instant. This one idea drives all of calculus. Let's differentiate f of x equals x squared from the definition. Expand x plus h squared to get x squared plus 2xh plus h squared, then subtract x squared. The x squared terms cancel, leaving 2xh plus h squared over h. Divide by h to get 2x plus h. As h goes to 0, the derivative is 2x. Now use that result. Since the derivative of x squared is 2x, the instantaneous rate of change at x equals 3 is 2 times 3, which is 6. That means at the point where x is 3, the curve is rising 6 units up for every 1 unit across. The tangent line there has slope 6. Let's tie it together. Take the slope between 2 points, then let the points merge by sending h to 0. The result is the derivative, which is both the slope of the tangent line and the instantaneous rate of change. We prove the derivative of x squared is 2x. Next, we'll learn shortcuts, so we never need that long limit again. Great work! Keep practicing with Nitya at nityazacademy.com for free lessons, worked examples, and practice.